Okay, when you think underwater hotel, what comes to mind? Probably incredible luxury, right? Fish swimming past your window, total serenity. But that's just the window dressing. The real story, from an engineering standpoint, is a nonstop, high-stakes battle against the raw, crushing power of the ocean.
I want you to really let this sink in. You are paying for life support. Yeah, forget the fancy sheets and the minibar for a second. Every single cent of that room rate goes towards the mind-bogglingly complex systems that have one job, and one job only, to keep you breathing in a place that is fundamentally hostile to human life. So this is the big mental shift you have to make. This thing, it's not a hotel. It's not really a building at all. You need to think of it as a submarine that just doesn't move. It's a pressurized capsule sitting in an alien environment that is constantly actively trying to crush it, freeze it, or shoot it right back to the surface. And that leads us to the first massive engineering problem. The real challenge, the first massive fight, is stopping it from launching back up to the surface like a champagne cork. It all comes down to basic physics. The hotel pushes a ton of water out of the way, and all that water tries to push right back up, creating this immense upward force. I mean, look at this. It's literally like trying to hold a giant balloon underwater. So how do you fight that? Well, you need something equally massive pushing down. We're talking hundreds of tons of solid weight, ballast, that's as heavy as a fully loaded airliner. And even that's not enough. They also have to drive these massive steel piles deep, deep into the bedrock just to pin the whole thing to the seafloor. Okay, so you've managed to pin it down. It's not going anywhere. Great. Problem is, now you've got to deal with the other direction. The absolutely terrifying, crushing weight of the ocean, trying to squeeze it flat from every conceivable angle. They call this hydrostatic pressure. It's just the constant, relentless force from the sheer weight of all that water above and around you. And for something brittle, like normal glass, forget about it. That pressure is an instant death sentence. It would just pop. It'd shatter into a million pieces. So the big question is, how on earth do you build those massive windows with those incredible views without the whole thing just imploding? And this is where the engineering gets just unbelievably clever. Check this out. Instead of trying to brute force their way against the pressure, the designers decided to use it. The secret is the material. Those giant viewing domes aren't glass. They're made of a special kind of acrylic that has a tiny bit of flex. So as thousands of tons of seawater press down, the acrylic actually compresses just a little bit. That distributes the force perfectly. But here's the genius part. It's that exact compression that squishes the acrylic against the steel frame, creating the most perfect, watertight seal imaginable. The ocean's biggest threat literally becomes part of the solution. It's just brilliant. But that perfect seal creates a brand new problem. If you're in a perfectly airtight box, what happens? You run out of air, fast. So now you face the challenge of creating, essentially, a mechanical lung. I mean, it's pretty obvious, right? You can't just crack a window for some fresh air. So you need a hidden, totally continuous system to do the breathing for you. It's a constant loop. You've got these massive industrial-strength HVAC systems up on the surface that are literally pumping fresh, climate-controlled air all the way down. And at the exact same time, another system is pulling all the stale air, and more importantly, the carbon dioxide you breathe out, back up to the surface. It's this silent, invisible lung just working away in the background, 24/7, keeping you alive. Okay, last big one, and this is something you probably never, ever think about on dry land: plumbing. See, in a normal house, gravity is your best friend. Everything just flows down and away. But down here, gravity is actively working against you. Think about it. You can't just flush things into the ocean. It all has to go up, back to the surface. So the plumbing has to be a completely closed, high-pressure system. Here's how it works. First, anything that goes down the drain or toilet hits a macerator, which is basically a grinder. Then, some seriously powerful pumps kick on to pressurize the whole thing. And finally, this system violently pushes that waste all the way back up, fighting gravity every inch of the way, into a holding tank on the surface. It's a pretty intense process for a simple flush. So let's pull back for a second. When you look past the incredible views of the fish, you forget about the fancy room service for a minute. When you really think about the constant upward force trying to tear it from the seafloor, the crushing downward pressure trying to implode it, and all those invisible life support systems working overtime, what is it that you're really looking at? What you're looking at is a masterpiece. An absolute triumph of engineering. It's a symphony of structural dynamics, fluid mechanics, and life support systems. It's not just a hotel room. It's a high-tech survival pod, just disguised as a five-star bedroom. And that, right there, is the real magic. It's a testament to the incredible human ingenuity it takes to let us survive, even for just one night, in a place we were never meant to be.